Alright, I know this stuff is review, but we are going to go over different types of measurement, how they're measured in the units of measurement, just to make sure we are prepared for the rest of the school year. Why do we measure? It's a way to collect data with different tools so that we can help get results and analyze the results of an experiment. Remember that our units that we use are based on the International System of Units. Most countries use the International System of Units in science, or that almost all countries except for the United States and some random island country, they use the metric system, where we use the standard system. So we have the International System of Units so that any scientist, no matter where they're from, can share the results, and they're going to be in the same units, and there's no confusion. Also, that metric system, um, which is essentially the same as the International System in Units, is based off the number 10, so it's easy to convert back and forth, easier to do calculations than the standard system that we use. Alright, first type of measurement is length. It is a measure of distance. Remember that a meter is the basic SI unit of length. We measure it with rulers, meter sticks, tape measures. You guys, I think, are pretty experienced with that by now. Volume is the measure of the size of a body or region in three-dimensional space. So the liters and cubic meters are the two different SI units of volume you can use depending on if it's a liquid or a solid. So liquid is liters and solid is in cubic meters. We'll use graduated cylinders for liquids. If we have a oddly shaped object, remember that we use displacement. So we put water in that graduated cylinder, and then we put the object inside of the water to see how much it displaces the water. And then if we have a rectangular object, we use length times width times height, and there's other volume formulas for different shapes like cylinders, but we're going to focus more on those rectangular and some of those oddly shaped objects for now. Mass is the measure of amount of matter in an object. So how many atoms essentially are making up how much matter is in whatever you are getting the mass of. So a kilogram is the SI unit for mass. The tools we use triple beam balances. Scales are very typical, but we'll be using our triple beam balances a lot in class, which I did not put on here for some reason. Temperature is one you are definitely familiar with. It's a measure of how hot or cold something is. We're used to seeing Fahrenheit in our standard system, but Celsius is often used in science. But Kelvin is actually the SI unit for temperature. So whereas most of the other units inside of the SI units are metric, Kelvin is not. And we use, of course, a thermometer to measure that. Area is the measure of how much surface an object has. So this is our square meters, which is our SI unit of area. So we measure the length and the width, and we multiply them together to find the area if we have a square rectangular object. If it's different shapes, of course, there are different formulas, but we are focusing mainly on those square and rectangular objects for this class's purpose. Density is the ratio of mass to the volume of a substance. So how much matter do you have shoved into the space it's taking up? So depending if you're talking about a liquid or a solid, it's going to determine your units. Liquids is gram per milliliter, and a solid is going to be gram per meter cubed. So something like a golf ball is going to be more dense than a wiffle ball because it's got more mass. Even though it's smaller in volume, it doesn't take up as much space. It's got more mass shoved into that small space than a wiffle ball, whose area is bigger, but it doesn't have as much mass. So to find density, you take mass divided by volume. So the more mass you have per volume, the bigger density you're going to have.